We are wanting to find the integral, okay, the integral of the square root of 2x plus 1, okay? Now that looks really funky, right? Like, what do you do with the square root? Let's make it a little bit easier by just saying that is 2x plus 1 to the power of 1/2, okay? Now, what do you do with that? There's like stuff in the middle. It's really uncertain. So let's simplify the problem a little bit and just ask, like, what happens if you were to find the integral of that, right? How would that work? So what happens is you plus 1 to the power there. Okay, so writing that out, that becomes 3 on 2. So how does that work? 1/2 plus 1 is 2 divided by 2. Combine those, and that's 3 on 2. Okay, so that might be a bit easier to remember. So throw back to fractions. Okay, and then what ends up happening is that you then need to divide by that 3 divided by 2. So divide by 3 divided by 2. And this is more fractions, right? Now it's an indefinite integral, so there's no like numbers at the top here and at the bottom. So we just say that is plus c. Now throw back to fractions, okay? When you have a divide, you can flip that and make it into a times, like this. Okay, that's the rule of fractions. It's just going to take a little bit of time to remember that, okay? And so finally, we can say that's 2 divided by 3x, 3 divided by 2 there, plus c. Okay, so that was kind of complicated, but we could figure out this one here. Now, we kind of need to do the same thing, but with the guts of it in there, right? The guts of it are now going to change. So we can kind of write it out like that 2x plus 1 and 3 divided by 2 plus c. Now, what do we do with this plus 2 now that's just appeared out of nowhere, right? Well, what ends up happening is that that plus 2 is the opposite of the chain rule. So let's kind of differentiate this to say, just to test out this scenario. So what happens if we differentiate this? Well, what we find is that the 3 times 2 comes down, and we minus 1. So remember 3 divided by 2. 1.5 minus 1 is just 0.5, 1/2. And that c just disappears. So c is meant to be like any number, like, I don't know, 3. And when you differentiate it, what is the gradient of a flat line, like 3? Well, it's 0, right? The ball doesn't roll anywhere. So that cancels out. But now what happens is we have to times by 2, because you remember the chain rule, right? When we differentiate that, we times by 2 there. So now we've got this extra 2. And this doesn't equal the same thing that we had at the top here. We've got this extra 2 here. So what we have to do is we have to divide by 2. So I think what's really easy is when you get these weird looking integral ones, they're only going to give you a question where there's like a 2 there, right? Like a constant or like a 3 or a minus 4. Okay, so you can go through the working out for the basic one with the guts of it being normal x, and then figure out what happens when you substitute the guts of it as 2x plus 1 or whatever the question is. And in this case, we need to divide by 2, don't we? So the final result of all of this is going to be that 2 divided by 3, and then we're just going to divide by 2 and write it all out here. So 2x plus 1, 3 divided by 2 plus c, okay? And that is our integral, okay? And so our final result is going to be 1 divided by 3, 2x plus 1, 3 divided by 2 plus c, and that is our final result. Okay, so take it to the simpler question first, and then substitute in your 2x plus 1, the guts of it, see what extra bit is left over, and it's a 2. To get rid of that, The opposite of times by 2 is to divide by 2, and that's what is done right here. So if you have any questions or recommendations, leave a comment below. I'd love to answer it.